What a great day to scroll through my email. Whoa, there's a new message by Elon Musk. Okay, it's my dear friend. Okay, let's see. Oh, it is Elon Musk. Good evening, Rahul. I need your help tutoring my newly adopted son named Solar X21E with his Mac homework. I cannot help him because I'm too busy building cars and rockets. You are the best tutor I personally know, and I will pay you with 20 Tesla Model S's. Please help. Thank you so much, Elon Musk. Oh, hmm. I definitely must help him. Let's see. I'm gonna say send. Hold on. Send me the map. Send me the map problems, Elon. I will help you. Now we have to wait for what he says. Oh, look like he replied. Let's see what he said. Hmm. I have attached the math problems he struggled to this email. Please send videos that are similar to a tutorial so it is easy for my son to understand. I am putting my son's future in your hands, so please take care. I really appreciate the help. Ah, he's so nice. Let's look at the problems. Download, then open. Hmm, I can see why he might have struggled. They look scary, but time to help him.
So this is my first equation, and let's get started. So because over here, the numerator has the same exponents, we can write the base, multiply the bases together, and then put 2 on the top. So it's gonna look something like cotangent of x in the bracket multiplied by cosine of negative x, all of it part by 2, 2 over there. And then now we can write cotangent of x into cosine of x over sine of x. All that multiplied by cosine of negative x over 1 in power. Okay. Now, let me go to decimals. Okay, now you can see over here, cosine of x is going to be red, and cosine of negative x is going to be purple. And in the graph, you can see that they both align the same thing, which means cosine of x and cosine of negative x has the same property. So I can write cosine of negative x as positive x. If you do that, let me just erase it. Cosine of x, right? And then you multiply these together, and then you get cosine of x squared over sine x multiplied by 1 is sine x. And then all that over 2. So when you bring in this 2 to the numerator and the denominator, you're going to get cosine of x, 2 multiplied by 2 is 4, so cosine of 4 over sine of x to the power of 2. So that's going to be our numerator. So now to the denominator, I'm going to write the cot of x as cosine of x over sine of x, all that to the power of 2 minus cosine of x squared. Now I'm gonna bring in that 2 to in the inside, so cosine is gonna be cosine of x squared over sine of x squared minus cosine of x squared. I'm gonna write a by 1 as a placeholder. Now because it's not in multiplication and it's in negative, so I'm gonna cross multiply. That's the only way to do it. So when you cross multiply, 1 multiplied by cos of x squared is gonna be cosine of x squared. And you transfer negative sign over here, and then sine x multiplied by cosine of x squared is going to be sine of x squared, and then multiply by cosine of x squared, and then you multiply the denominator together, so it's going to be sine of x squared. And now I'm going to factor these two together to factor out cosine of x squared, which will result in 1 minus sine of x squared, it's going to be in the bracket, and then multiply by cosine of x squared over sine of x squared. So we can turn this into a cosine of x squared because of the trig identity, and then it's going to be cosine of x squared multiplied by squared over sine of x squared. So when the bases are the same, you can just add the exponents together. So this is going to be cosine of x equals to 4 over sine of x squared. And that's our denominator. And you see over here, our numerator and the denominator are the same thing, which means our simplified answer is going to be 1. Boom. Turn off. Okay, now we're supposed to do proofs for this. We're going to prove this is equal to 2 cotangent of theta. So let's get started. Okay, so first I'm going to turn both of the cosecant of theta to 1 over sine of theta. So, and then we're going to turn cotangent to cosine over sine over theta. So let me use that really quick. Theta. It's gonna be a minus because there's a minus over here, and then cosine of theta over sine of theta. It's theta by there. And then all of that minus 1 over 1 of sine theta, this time plus cosine of theta by sine of theta. Okay, now both of these have the same denominator, just sine of theta. Wait, boom. So we can combine them together without like any hassle. So it's gonna be 1 over 1 minus cosine of theta or over sine of theta. And it's going to be the same case for over here, except this negative sign is going to be positive over here. So 1 plus cosine to theta over sine of theta. Now we're going to use our trig identities to turn these two into stuff. So this is going to turn into tan of theta over 2. It's going to go in brackets. Okay. And then all that minus 1 over, we can turn this into cotangent of theta over 2, right? And then we're going to turn the cotangent, because we're going to match it with tan. So we're going to turn this into 1 over tangent of theta over 2. Boom. And it's gonna be the same thing over here. And now we're gonna flip this, basically simplify this complex fraction, and it's gonna get us tangent of theta over 2. It's gonna be over. It's gonna yeah, I'm gonna go to the back side. So now it's gonna be 1 over tan theta over 2 minus tan theta over 2. And then I'm gonna put a divided by 1 as a placeholder because we're gonna be multiplying, and we're gonna cross multiply these two together. And when we do that, there's gonna be 1. Our answer is gonna be 1 over tan of theta over 2 squared over tan of theta over 2. And now we're going to use our double angle formula, one of our double angle formula, to turn this into something easier. It's going to be 1 over tan of theta over, the whole thing over 2. And now we're going to simplify this complex fraction again. So when we do that, it's going to be 2 over tan of theta. And now we can turn this into our cotangent. So it's going to be cotangent of theta of 2. And we proved it. This is our answer. And so this is my third equation, and let's get started. So we can see cosine of theta is equal to negative 3 over 5. And according to SOHCAHTOA, we know that negative 3 is going to be the adjacent, and then 5 is going to be the hypotenuse. So I'm going to write it over here. Adjacent is negative 3, and the hypotenuse, which is h, is going to be 5. So now we have to figure out sine first. So we know sine is opposite over adjacent, but we don't know what opposite is. So let's write it as x. We can find x by using Pythagorean theorem. So our hypotenuse is 5. Then our adjacent is over here. It's going to be 3. And then opposite is going to be x. So now we're going to do negative 3 squared plus x squared equal 5 squared. And then when we complete this, we're going to get x equal to negative 4 or 4. However, because we our restriction is going to be on the third quadrant, which is going to be like over here, this side of the graph, we're going to be using negative 4 as our x coordinate. So our opposite is going to be negative 4. Okay, now we can write sine of theta equal to negative 4 over 5. However, what we need is sine of 2 of theta. Sine of 2 theta equals to what? So we're going to use the double angle formula for this. So which is 2 sine of theta and multiplied by cosine of theta. So because we already have sine and cosine over here, we're just going to plug it in. So it's going to be 2 multiplied by, what sine of theta is going to be negative 4 over 5 multiplied by negative 3 over 5, which is our cosine. And then when we multiply the denominator together, we get 25. We multiply 4 and negative 4 and negative 3, we're going to get 12. And now we had to multiply 2. So, wait, when we do that, okay, so we're going to get 24 over 5, 25, which is our answer. So this is the fourth equation, and let's get started. So first we see sine of theta over here, and there's sine of theta over here too. So let's just cancel them out by minusing this thing. So this thing cancels out, and you do sine of theta over here. It's gonna turn into 0 over negative this sine of theta plus sine of theta, and then instead of cotangent, we're gonna write cosine over sine of theta. Hold on. Theta, and then divided by sine of theta. And there's the sine of theta over here and over here, so we can just strike them out. Boom, boom. And now, we just gotta rewrite this. But there's a plus sign, so it's plus theta. And now we're gonna multiply this by 2. Let me factor it. So use that. It's gonna turn into 0 equal to negative 3 square root over 2, and then sine sine of theta. There's supposed to be theta over here, but then plus 1 over 2, then cosine of theta. Okay, so now, I mean, hold on, the whole thing should be over 2. Remember, from there we're multiplying this, so we're gonna turn these, that plus 2 and negative square root of 3 over 2, into sine over things. So it's gonna turn into 0 equals 2 negative sine pi over 3, and then multiply that thing multiplied by sine of theta plus this thing turned into cosine of pi of 3, and this, and then where's the last one? Boom. Cosine of theta. Then the whole thing. So now, as you can see, we can use the sum and difference equation over here. So this will turn into 0 over 2 cosine, the cosine is the sum and difference for the cosine, and then that's going to turn into these values. So it's going to be pi over 3 plus theta. So now we're basically going to divide 2 on both sides, and this is going to cancel out. This is going to 0 divided by 2 is going to be 0 anyway. So 0 equals cosine of pi over 3 plus theta. So now what we're trying to figure out, hold on, let me just do this. What we're trying to figure out is cosine of what you can add to pi of 3 that will turn cosine of that digit to 0. So when we go to the unit circle, we can see cosine is going to be the x digit. It's going to be 0 on 3 pi over 2 and pi over 2. To get that, we're going to need to add something to pi of 3. So what we can add to pi of 3 to get to pi over 2, we can add pi of 6, which is 30 degrees, and pi divided by 3, just 60. The two add together to make 90, which is pi over 2. So 1 over theta is going to be pi over 6. Then other value, which turns the cosine of the whole value to 0, is going to be 270 degrees, just basically 3 pi over 2. So what we can minus 270 minus 60. 270 minus 60 is going to be 210. 60 is basically the pi over 3, and And 210 is going to be 7 over pi in radians. So our second value is going to be 7 pi over 6. And that's our answers. So this is the fifth equation, and let's get started. So first, I'm gonna let x be sine of x, just to solve this. So I'm gonna rewrite the whole thing as 6 over x. Wait, I don't need to write this one. So it's gonna be 6 of x squared minus x minus 1 equal to 0. So when I factor this, it's gonna be 3 of x plus 1, and then 2x minus 1 equal to 0. And then when I set them up to equal to each other, so it's gonna be x equals negative 1 over 3, and then x equals 1 over 2. So I'm gonna plug in sine of x for x. So it's gonna turn into sine of x. I'm gonna do this one first, right quick. And then it's gonna be negative 1 over 3. So now I'm gonna switch this sine to this area. So it's gonna turn to sine to the power of negative 1, so basically arc sine of negative 1 over 3. Right? And then when I put this into the calculator, I get negative 0.339. It's like 3 decimal places. And then because of it's in sine, I'm gonna do plus 2 pi n. That's our first answer. Let's go to this next one. So for this, I'm gonna write sine of x equal to 1/2. So when I go to the unit circle to look, you can see that the y value should be 1.5. So there's y value is 1.5 everywhere. It's like 2 pi over 6, right, over here, and then over here, which is 5 pi over 6. Those are the only two areas where the y value is 1 over 2. So then that means for here it's gonna be x equal to pi over 6 plus 2 pi n. That's our first answer. And our second answer is going to be x equal to 5 pi over 6 plus 2 pi n. So those are all our answers. And yeah. So this is the sixth equation and the last one. So let's go. First, we're going to divide by 2 by both sides. So when you do that by both sides, it's going to be tan 5x multiplied by 5x equal 8 divided by 2 is 4. And now I'm going to bring the tan to this side, and I do that, it's going to be 5x equal to tan to the power of negative 1, so basically arctan, multiplied by 4. And then because it's tan, I'm going to add plus pi n, and now I can divide by 5. And it's going to cancel over here, and then divided by 5 over here, and over here. And to get the exact value, not exactly, well, the solution, so I had to put this whole thing into a calculator. And when I do that, it's going to give me a long decimal, so I'm only going to get the 3 decimals, the first 3 decimals. So it's going to be 0.265 plus pi of n, pi n over 5. And that's our answer.
Okay, now that I have finished my videos, I have to send it to him. So I start. I'll say I have attached the this this email. Elon, show this to your son and hopefully it I don't have to attach it. Mm, it's uploading. Let me change that. That really helps, not gonna lie. And let's send it. Let's see what he says. Let's see what he said. Hello, Rahul. He watched the videos and said they were amazing. His grades went from an F minus to an A plus, and Harvard University just sent an invitation letter to him because of your help. So to thank you, I will transfer you $15 million to your bank to your account along with the 20 Tesla Model S's. Enjoy, Elon Musk. Oh my gosh, it's $15 million. I can retire now. Nice.